Greetings. Welcome to Introduction to SQL for Excel Users, Part 13, Basic Dates. I am your instructor, Dave Langer. The focus of this video is dates and times. So arguably the time dimension is the most important consideration in business analytics. For example, business performance is often measured by a key performance indicator, a KPI, and analyzing those over time is the heart of so many business analytics scenarios. For example, is our new marketing campaign working? Are our sales actually increasing? Are our expenses actually decreasing? Have we actually changed the performance of a particular conversion rate on our website? You name it. Basically, anything you can think of that's of importance to executives or decision makers in a business can be measured by a KPI, and it is most analytically useful to look at these KPIs over time. Next up, another example is if you create a customer churn predictive model. Features that you engineer for predicting whether or not a customer is going to leave you for a competitor are often based on the time dimension. How long ago did they most recently contact customer service? How often do they contact customer service over a particular time frame? How often do they buy? When was the last time they bought? All those sorts of things. So those sorts of features also make heavy use of the time dimension. So the time dimension is wildly useful in business analytics, arguably the most important consideration. Now here's the problem. Working with dates and times is hard. And let me just give you a couple of examples. Different date formats across the world, that gives you problematic types of things. So for example, does this string literal of 02/05/2020 mean February 5th, which it does if you're in the United States, or does it mean May 2nd? Like for example, if you live in Great Britain, in England, in the UK, this is not the same thing as it is in the United States by default. That's one difficulty. Now the other difficulty is time zones. Is this date here, 02/05/2020, in Mountain Time, where I live in the United States, or is it UTC time? So these are just a couple of simple examples of how working with dates and times is complicated. And as an analytics professional using SQL, for example, you need to be aware of this because the time dimension is so important, so important. Okay, what about time? So language neutral literal representations of dates and times use the 24-hour clock when those literals actually have a time component. They don't have to. A language neutral string literal for a date or time could either be a date and a time, or just a date, or just a time, as we'll see throughout this tutorial. That just means essentially we have hours, we have minutes, and we have seconds. So just to really solidify this, a full-blown, quote unquote, language neutral string representation of a date and time would be something like this. So if I wanted to do 1:34:44 p.m., this is the way the US folks think about it, on February 5th, 2020, it would have this representation. Now notice that I am ignoring time zones right now. I'm not saying this is Mountain Time or Eastern Time or UTC. I'm not actually specifying it. I just want to focus on this idea right now for this video. That's why it's called basic dates. So 2020, 02, 05, 13, 34, 44 is 1:34:44 p.m. on February 5th, 2020. Okay, so that's the basics. So to really solidify these concepts, I'm going to go ahead and flip over to Excel now, and we can talk a little bit about how Excel represents dates to get you grounded on the idea and then on the concepts, and then we'll move over to SSMS and see how SQL, how T-SQL and SQL Server handles basic dates and times. Okay, here we are in Excel, and I'm just going to expand this cell so that this column so that I can have a little more working room. I am sitting here in Excel. Not surprisingly, as an American, my computer is set up for US English, and that has particular implications in Excel. So for example, I can type in the language neutral representation of 1:34 p.m. and 44 seconds on February 5th, 2020 using a language neutral 34:44 using a language neutral representation. Okay, so I can type that in. And if I hit enter, look what happens. So Excel loves you. Excel wants you to have a great experience working with data. So what it says is, hey, I recognize that pattern of what Dave typed in. And I also know that his system, his computer, his version of Windows is configured for US English. So I will take that language neutral representation and change it into something that he's going to recognize. And if I actually go over to the cell here, you can see up here in the formula bar that this is nice US English representation, right? February 5th, 2020, 1:34:44 p.m. Great. Right? It's awesome. Now, behind the scenes, what's going on is this. Excel actually represents a date as a number. Essentially, it is a number with a decimal point in it. And basically what it does is that number tracks the elapsed time from midnight on January 1st, 1900. And everything to the left of the decimal point, the whole number aspect, is the number of days, the number of full days since January 1st, 1900. And then the fractional part is what fractional percentage of a date has happened since then. So for example, if you had, 3,444.1234 would be like some date way after January 1st, 1900 at midnight. So that internally, Excel represents a date as a number, and it's an offset from January 1st, 1900 at midnight. So it does that, but it's also smart. It can say, okay, look, if I use that representational format, that number, I can then reformat dates any way I see fit based on the locale, based on the language setting of the computer in question. Now, this is important. Okay, this is important because you might be used to seeing dates like this if you're in the US and not really think about it. But when you start working with SQL, you tend to use language neutral representations all the time, just because they're a lot more unambiguous when you start doing date logic. Okay, so we can do some cool stuff in Excel. So for example, there is this function called now, which returns the current date and time format as a datetime. So if I type in now and hit enter, whoops, didn't do that right. There you go. You can see that at the time of this recording, it is October 4th, 2020, around 1:35 p.m., oddly enough. That's what time it is as I'm recording this video. And notice that it automatically formats the date and time. But if I look at the formula bar, it's an invocation to now. So this is super important. This is really useful because you often, when you're working with SQL, you're going to use the equivalence of now to allow you to perform date logic calculations, which we will see in a subsequent video. Now, Excel can also handle dates and times separately. As I mentioned earlier, you can have language neutral representations of dates and times, just dates, and just times. So for example, I can type in 2020-0205, which is the language neutral date representation of February 5th, 2020. If I hit enter, Excel just formats it for me automatically. But also I can type in, if I want, I can type in 133444 and hit enter. And notice that Excel doesn't actually translate it right here in the cell, but if I look at the formula bar, it's actually giving me the US representation. So the whole point of this, and those of you that are Excel wizards or in sorceresses are looking at me going, Dave, wow, why are you going through this so slowly? And the answer is Excel handles so much of this for you behind the scenes that it can be easy to take all of the subtleties of dates and times for granted. But when you move over to SQL, you can't really do that because SQL is super, super explicit. It doesn't do much for you. So you really need to know a lot about dates and times and how they work. And that's because, as I mentioned in the slides, the time dimension is so important in business analytics. So when you're using SQL to pull data, manipulate data, and or to conduct analyses at scale directly in the database, you have to be cognizant of all of these subtleties when you work with dates and times. Otherwise, your analyses are going to be problematic. I'll use that word, problematic. Messing up date logic is so easy. And when we start talking about time zones later on, you'll see that it gets even more complicated. But this is enough for right now. So I'm going to go ahead and flip over to SSMS so we can start seeing how SQL works with dates and times. Here we are in SQL Server Management Studio, SSMS, and you can see here I've got some SQL. Now the first thing that I want to mention is that Generally speaking, in Excel, you typically don't worry about combination of a date and a time, or a date or a time as distinct concepts, as distinct formatting. Usually you don't worry about that sort of thing in Excel. You just allow Excel to work its magic behind the scenes. It infers a lot and does a lot for you automatically. Excel is awesome that way. SQL, different. You got to be explicit. When you're working with dates and times or any other type of data in SQL, you have to keep in mind that SQL is extremely explicit in how it works with data, so you need to write your SQL code accordingly. So what you can see here is I've got 3 language neutral representations of February 5th, 2020 at approximately 1:34:44 in the afternoon. Oh, and by the way, just so you know, this date has no special significance. I literally just pulled it out of thin air. So, but you'll notice here, we've seen cast before. We saw that in a previous video. That's a way we can transform in SQL one type of data to another. In the previous video, we used cast to transform integers into decimals. That is, numbers without decimal points into numbers with decimal points. But you can use cast to transform all kinds of things. So for example, this right here is a string data type in SQL by default. So using this line of code says, okay, I don't want you, SQL, to treat this as a string. I want you to actually transform it from the string representation, the language neutral string representation, to an internal data type that T-SQL and SQL Server understands as a datetime, which is, not surprisingly, is a format that has both the date component and the time component. And you can see here, if I run this line of code real quick, it shows you exactly what you would think you would see. Now notice there's no column name because I don't have an alias here, but it says 2020-0205, and notice it uses the 24-hour clock. This is because SQL, T-SQL, and SQL Server by default uses language neutral representations with the 24-hour clock, right? Which is why it's important to understand them and know how to work with them. Now, one thing that's interesting is that notice that you also get a fractional part here. So you get your hours, you get your minutes, you get your seconds, and then you get your fractional seconds. As we'll see later on, this is important because SQL, T-SQL and SQL Server has the ability to track time all the way down to around 100 nanoseconds. So this is important, right? What level of accuracy, what level of fidelity do you want in your date and time data? So next up, we can say, look, take this entire string neutral literal and just transform it to a date. And as you might imagine, SQL says, sweet, I'll just go ahead and lop off the time portion because the date format, the date data type in T-SQL does not have a time component. It only stores the date component. And notice this is what you get out. This is great. But also notice subtly that dates and date times aren't necessarily exactly the same thing when push comes to shove, because notice that a date actually has less information in it than a date time does. Lastly, just like in Excel, you can also work directly with just time. And ignore this little parentheses 0, close parenthesis for the time being. I'm going to talk about it in a few minutes here. And you can see here that we get just the time aspect. So it lops off the date and it works with just the time. Now this is going to be super important, as we'll see later on in the series, that you need to understand, am I working with dates? Am I working with times? Am I working with date times? If I'm working with date times, at what level of accuracy am I measuring the time aspect? All of these things matter when you start doing SQL and you rely on date logic to actually pull records, analyze records. All this is very, very important. Okay, moving on. To give you an example, just to show you, I've got a language neutral literal date string here, which is once again February 5th, 2020. And I'm telling SQL, hey, cast this bad boy as a date time. And we can run this code, and not surprisingly, this is what we get back. SQL says, cool, no problem, Dave. I will take this portion. You gave me the date. I'll fill out the date portion of the date time data type, the date time formatting. But since you didn't give me a time, I will default to midnight. SQL says, cool, no problem, right? This is a legitimate date. I interpret this. If you make me want to interpret this as a date time, I will interpret it as 2020, 02, 05, and then 0000, all these zeros. Essentially, February 5th, 2020 at midnight. Now this is really super important because notice that this right here is not the same as this. Strictly speaking, these two things are not the same. So when you start doing date calculation logic in SQL, which we will do, this starts to become important because this string literal does not have all the same information as this string literal. And there are a number of situations where if you're not careful of this, your date logic will not work 100% correctly. So this is why I'm going over this in exhausting detail. This stuff matters. The data types matter. A date time created with only the date portion is different than a date time created with the date portion and the time portion, even if the respective date portions are exactly the same. Types matter in SQL a lot. As I mentioned previously in the Excel section, the Excel now function is wildly useful stuff, and conceptually this idea is used all the time in SQL-based analyses. The SQL equivalent of now is something called current timestamp, and I'm using this particular function because this one is most portable across database platforms. SQL Server, T-SQL supports other types of functions that will actually give you the current date timestamp, but they are T-SQL specific. So for example, there's one called getDate. I'm not going to use that because it is not as cross-platform as using current timestamp, which SQL Server supports, so that's why I'm using this one. So I can just run this query here real quick, and I get back some interesting information. Note we've seen this. This is not surprising. At the time of this video recording, it's around 1:47 p.m., 23 seconds, and some fractional aspect here, 0.353 seconds. That's when I ran the query based on the time of my laptop at the time of this recording. And you can see here that I can also cast current timestamp as a date, and I get just the date portion, and I can cast current timestamp just as a time, and I get the time portion. Now notice this is super, super important, that I only get 0.353 here for a date time. But when I casted it as a time, I get all the way down to 100 nanoseconds. 0.3533333. So even here, notice that the current timestamp is returning back a different level of data, a different level of date time accuracy than what the time aspect by itself is showing. So this is extremely important. As I mentioned earlier, SQL Server can get down to 100 nanoseconds worth of measurement. And if you cast something as a time by default, you get it all the way down to 100 nanoseconds. We can see how to control this in a second. The next query will show how to use a parameter to the time casting to actually tell you what level of accuracy in the fractional second component that you would like. Lastly, we can see here, as I promised, how we can work with timestamps. Okay, so here we have this, not surprising, but notice that if we parameterize the casting of current timestamp to time, and if we use a parameter of 0 here, as it's wrapped in parentheses here, SQL Server says, okay, Dave, cool, so awesome. You want the current time just down to the seconds. That's all you want. That's cool. That's what time parameterized with 0 means. Current time to the second. Current timestamp parameterizes 3 with the time, gives you the milliseconds, which you can see here, right? Milliseconds, no problem, which by the way is notice that that's the default fidelity of a date time, 0.230, 0.230. And then lastly, you can do time either with nothing parameterized, which is the equivalent to parameterizing time with a 7 by default, and that gets you everything with a full accuracy, which is down to about 100 nanoseconds. So there you have it. So that's enough for today. That's quite a bit of goodness, but these are the basics of working with dates. And now that we have the basics of working with dates, we can now return to the RFM analysis that we saw in video 11 And we can complete the recency, the R aspect of the RFM analysis, because now we know something about dates, and we'll actually do some date calculations. Until next time, please stay healthy, and I wish you very happy data sleuthing.